Okay, yeah. So we are live and we are very happy. It's a very special moment that we have a special industry session um, with eminent members from Saankhya Labs, and they will share with you the workings of the industry and their products and their achievements and the future goals and even career opportunities. So I hand over to Professor Sharayu Moharir. She's um, professor, associate professor at IIT Bombay. Thank you, Sharayu.
Thanks and welcome everybody to this panel, both panelists as well as the audience. I It's my pleasure to introduce Anindya Saha. He is the Chief Technology Officer at Saankhya Labs with over 25 years of experience. He is an expert on software-defined radios and leads the design and development of baseband and RF subsystems for the lab, including radio development for 5G. He has been instrumental in SDR platform development and holds several fundamental patents and publications in this domain. Mr. Saha, I hand over to you to take this session forward.
Thank you, Dr. Sharayu. I hope I am audible.
Yes.
I'll go through a brief presentation, which is our corporate presentation, uh, and I'll just share my screen uh, for the same. Uh, Please let me know once it is visible. Okay, is my screen visible?
Yes.
Okay, thank you. So I will go through the corporate presentation, which we for Saankhya Labs. Essentially, typically corporate presentations turn out to be a little bit boring, but I will try to inject into this, the culture of innovation and how people work, as we go through the journey of Saankhya Labs. So let me jump into who we are and how do we identify ourselves. So we identify ourselves as a premier semiconductor and a wireless communication solutions company. We are one of the first fabless semiconductor companies in India who have taken, our SDR to production at scale. We also take pride in having a strong, I would say, uh, innovative innovative index. You can see 70 international patents that we have, and we span a huge area, right from the RF, I would say, antenna to building SoC, system on chips, for Saankhya Labs, and that is what determines the kind of products that we build. We have done a lot of field deployments, especially in satellite IoT systems. My colleagues, we are going to talk about some of them in the later slide, in the later part of the presentation. So, and we have done about 20 million odd investments in the research and development. So if you look at the kind of domains that we are looking at currently, in the lower part of the slide, we are looking at mainly open RAN solutions for 5G radios, including the RU and the DU. We also have pioneered a solution which we call as 5G broadcast, and then we have been doing satellite IoTs for a long time. We also, ISRO is one of our partner companies, technology partner companies, for whom we have been building a lot of stuff for India. In terms of awards and recognition, in 2020 we have been awarded as recognized as one of the high growth companies, and that is one of the vectors which we want to continue acceleration towards, and we take a lot of pride in being recognized as one. So if you go to a little bit into the evolution, how the company has evolved, we started off as a fabless semiconductor company, and we built two generations of software-defined radio silicon, primarily doing a lot of flexible baseband in a very innovative way. And then we did fixed wireless access products as well as satellite products, mainly targeted towards rural broadband. And then we went to the vector of doing 5G broadcast, which is mainly ATSC3 And then, currently we are looking at the RU and the DU solutions, which is currently in work. And again, being done, in terms of being done in, keeping the parameters of the ORAN compliance in mind. And of course, there are plans of doing, another generation of SDR targeted towards the infrastructure, as well as in future, our roadmap goes on to do what we call as cognitive RAN or AI-enabled RAN, and then and finally, our goal is to see how we can virtualize the handset. So if you look at the progression, we started off as a fabless semiconductor company, but then we kind of graduated to building systems, because that is where we found that we can get more value for the kind of IP potential that the company has in terms of the engineers, in terms of the expertise which they have. And now, today, we have matured ourselves to building full-fledged communication platforms which are targeted towards 5G and beyond, both in terms of, if you look at the broadcast as well as the broadband. The next slide actually presents the evolution of how our SDR platform has gone from the first generation to the next, the second generation, and then there's something which is again being built. So we built our first generation, SDR as a 40 nanometer ASIC, and this was one of the earlier times, sometime in 2010 when we built this, and at that time, multi-core was just coming into fashion. People didn't know about this term at all, much, and we were in fact one of the pioneers who figured out that we can decompose any communication signal chain into a class of processing elements, and once you do that, you can actually do a very nice mapping between them and the kind of processing code that you need. So our heterogeneous multi-core DSP is actually built completely grounds up and completely in-house. This is an ISA which Saankhya Labs has developed indigenously. There is absolutely no licensing here. And the instruction set, the tools, the compilers, everything has been built grounds up, by the innovative engineers at Saankhya Labs. One of the important things that we should keep in mind is that we kind of built it using the consumer grade market in mind, and today we think we can say that we have been very successful in that, because we have been able to support like something like 23 waveforms on a single chip, or using a combination of multiple chips. Going to the second generation, this is something which we did, I would say 3 to 4 years back, and it was done in 28 nanometer. Again, very low power, but then not compromising on the throughput. So if you look at some of the metrics that we have, I think this goes really beyond 50 to 60 Mbps higher. But then if you look at the metrics, some of the metrics that you can see in terms of power consumption per data rate, so we are one of the industry's lowest if you start comparing with the likes of the common COTS products that are usually available. So even in the second generation, the instruction set architecture was matured from the first generation. People put all the learnings, all the fields related learnings that we have, we matured our ISA, and we built a far more robust ISA, which could not only handle the previous generation radios, but also new radios. So essentially, if you look at this platform, the main target was to do radio processing, modem processing, very, very customized for doing baseband, and very high throughput baseband at lower power. So a lot of innovation in terms of not only design, but also in terms of how it is architected, and what are the kind of algorithms, the baseband algorithm, the baseband processing that goes into it has gone in. And currently, we are in the process of building our third generation, which is meant for 5G infrastructure and beyond. And this is going to be a massively parallel architecture and inherently cloud native. So this is something which is in work. And a significant, I would say, a significant breakaway from what we have done in the past is that we want to introduce AI functionality into this for handling what we call as RAN AI, and then there are thoughts of how to make this as an open instruction set architecture. And then if you look at the roadmap, the fourth gen, this is really a little bit far fetched, I would say, but this is something which we are continuously thinking about, is to build more like an AI RAN compatible kind of infrastructure chip, where we will have a lot of observability of all the RAN metrics available to do more optimized, network deployments and giving far better KPIs, when somebody uses it in their infrastructure. Now, having looked at the SDR platform as well as the way we have evolved, let me touch upon some of the key areas that Saankhya Labs today is spending time on, investing heavily. So the first one is 5G RAN, and we have a very talented set of leaders with us who will be speaking on this aspect later after me. So this is basically again based on Open RAN concepts for both infrastructure and device, and this is basically being pitched as something which is elastic and also very innovative. Frameworks have been put around it to make sure that the DU or the RU that is built is really, really portable across platforms. So again, what we have done is we have put the fundamental principles of software-defined radio, which are kind of, I would say in the lifeblood of our engineers here, has been put here into action to really build something which is going to be very scalable and very future-looking. The next one is 5G broadcast. This is something which we have a product actually, and we are doing some trials, advanced trials. We are pioneering a concept called direct to mobile, and then we also have some work going on in broadband broadcast convergence with some kind of spectrum sharing approach. Now, this is also a work which we are fanning out into some kind of a standardization activity called broadcast offload in TSDSI. And then, but today we have a working solution of this, a working prototype, which we can really demonstrate. Coming to satellite communication solutions, again, there are speakers after me who are going to talk about this. We take pride in having satellite IoT and satellite communication solutions. Our teams have really built, both the hub side and the terminal side solutions, which operate in most of the popular, available frequency bands. So essentially, these are the high growth technology sectors. So anybody interested in 5G RAN, broadcasting, satellite communication, Saankhya is really the place to be, because this is something that the team here, that the engineers here breathe day in, day out. I think the other important thing I want to say is that most of the things that we do here are not relying on anything which we do outside. If the entire technology is indigenous, it is homegrown, and it is done completely out of India. So that is one thing which I really want to emphasize. And people, or I would say engineers in Saankhya, are really filing a lot of patents on all these three domains. This is actually a little bit of a product portfolio. We have the OpenDU, the RU, and what we call as the RAN intelligent controller, the RIC solutions, which is what is in work. This will again be detailed out, but the OpenDU is a combination of the DU hardware platform as well as the DU software platform, which not only reduces the total cost of ownership for the infrastructure market, but also allows you to make it portable and open. In the middle, you can see a lot of 5G RU. So basically, we are building a lot of radio units targeted for, I would say, not only India, but also the world. And this is where we also plan to do some more innovations by using our SDR chip to give differentiated features. And then we have the RAN intelligence controller. We have a technology which we call as radio mapping, using which we can do some AI-based network optimization. So this is something which is going on. And a lot of these are kind of future-looking. I mean, we are not looking at just 5G, but then what we'll do 5G and beyond. So a lot of the platforms that we build are very, very forward-looking, and and you, I mean, if you talk to, when you hear the engineer, the leads who are going to talk after this, you know, you will get a feel of how the direction in which we are going. This is a little bit highlight on the 5G broadcast solutions that we have, and these products I would say are already available today. So the first one is the broadcast radio head, which is basically a low power, low tower technology by which, you know, we can we do a broadcast transmission in, and this can easily pair up with a high power, high tower transmitter uh, to to deliver a very uh, high density or high throughput SFN solution, which can also be localized. So there are some trials going on, and we can talk about it offline. We have built a broadcast media distribution platform. We call it as the 5G broadcast core, which also enables offload and also, you know, talks to various OTT platforms, and it also enables us to do direct delivery of OTT content via broadcast to the mobile. And the last one is a very significant piece of work that Saankhya has done, where we have introduced a low power mobile terrestrial receiver in a phone. And that is, the phone is called as actually Mark 1. You can definitely look it up, Google it up. And what it enables is to receive live TV signals directly on the mobile without cellular. And this is something which is being trialed and in partnership with a lot of other companies, and you know, there is something which is likely to come later. So we have a version which is embedded in the phone, as well as a version which is sold in terms of an additional accessory to the phone. Coming to satellite solutions, which we talked of, we have solutions targeted for asset tracking, as well as the hub site, which basically sits in a data center or a network control center, as well as satellite IoT terminals. And these are, these basically enable real-time tracking of the assets. The hub site is something which basically sits on the hub. Basically, it has the modulation and demodulation in a central location. And the satellite IoT is something which is very, very popular. And I think there's going to be a little bit details of this as we come along later. And this allows us in doing, in providing, you know, satellite IoT solutions for remote areas, especially in high seas or even on top of trains, where we have one of the solutions. So this slide actually covers why we encourage people to join Saankhya Labs. We have been pioneers of the software-defined radio. We have the full portfolio in terms of going all the way from chips, silicon solutions, to the systems and building boxes. We are, I mean, the way we have been thinking, the way engineers think here has been very disruptive. I mean, you can see the patent portfolio already talks about that. And we have a full spectrum of products for different applications going into broadcast, broadband, and satellite. And we have a good field deployment experience, especially with our satellite, and then that is something which we will carry forward towards the other products. If you look at our USPs, these are the three areas where we have a lot of expertise in-house, especially RAN infrastructure, VLSI architectures, and even virtualization solutions, especially for the 5G radios. And I'll leave it at this point for speakers to talk about it later. I think this is just showing a slide of the customers that we have had so far, and I think that's all that I had. So if there are any questions, I can take it up, or we can even do it later. I will stop presenting.
Yeah, thanks, Anindya.
Yeah, so I think there is echo because at the same place, so only one mic should be on, then it will work fine. Yeah. So thank you. Please turn on your mic, Srinivas. Thank you.
Yeah.
So I'm Shrinivas Bhat from Algorithms team, principal engineer. Yeah, so I am along with Sunil and Sudarshan. I will be essentially going through the same presentation. Yeah. So you are able to hear me, right?
Yes.
So yeah, the first slide. The slide that I'm going to cover is a precursor to the details of DU and RU, which Sudarshan and Sunil will be covering.
Shrinivas, can you share your screen, please? Nothing is visible.
Okay. He has to enable user presenter.
There is an issue with the screen sharing. Looks like.
No, not it. Is screen sharing visible or?
No. Are you trying to share the entire screen or a PDF?
Entire screen.
Okay.
Actually,
Is it?
Sudarshan is sharing the screen. Actually, we are all in the same room, so only one of the person is sharing the screen.
I'll stop sharing. Failed.
Yeah, other member can share if possible. Yeah, we can see now your screen. Thank you.
My slides will be a precursor to the details of the DU and RU that Sunil and Sudarshan will be covering. So basically, the first slide says that typically the evolution of the RAN. So we have moved from traditional RAN, where actually we had the layer 1, layer 2, layer 3 as part of BBU, and the RF front end and all the analog converters, right? And A to D converters and all that part of RRH. So from there, we have evolved into first we had a disaggregation at layer 1, layer 2, layer 3 level. Layer 3 became a part of a CU, and layer 1 and layer 2 was part of the DU, and the other components, the RF and the analog components, were part of RU. From that, we actually evolved towards an ORAN where there was a split up between the within the layer 1 itself actually, and part of layer 1 became part of ORU, and with this actually a single ODU could actually serve multiple RUs. So the advantages that we got with this kind of an architecture is where actually multiple ODUs, right? If we could have, we could build COM kind of an architecture where the coordinated multi-point kind of applications and all, right? We could serve with this kind of an architecture. Can we go to next slide? Yeah, so this slide basically highlights what are all the key features of the 5G, right? And the IMT 2020, right? So they have given certain KPIs actually, which was a target for the 5G NR, and we could see that considering the various applications like EMBB, MMTC, URLLC. So in EMBB, basically
it's for the broadband, and MMTC is like for massive machine type communications, and URLLC was ultra reliable low latency communications. And we could see that basically all the KPIs that is met for MMTC, URLLC, and EMBB, right? So they have their own curves with respect to APIs. But if we put all of them together, right, so we are able to meet the IMT 2020 performance indicators in 5G. And there are some of the key features as part of 5G which could enable this which could enable the us to meet this key performance indicators. So basically, we had coming from LTE, right? So LTE supported only 15 kilohertz kind of a numerology, but the 5G supports numerology of right from 15 kilohertz to 240 kilohertz, and the bandwidth support also went up to 200 megahertz, and the band support also evolved up to 60 gigahertz. Then to increase the layers in MU-MIMO and SU-MIMO, right? So there were some enhancements to the DMRS port. So now the DMRS ports could use, along with the time and frequency orthogonality, they could use CDM to increase support for higher number of layers. Then we had CSI and RS and SRS based beamforming modes. SRS supports orthogonal frequency or time cyclic shifts to support a higher number of antennas at the UEs. Additional PRAT formats to support variable the cell size variations. Then we had modulation schemes up to 256 QAM, reaching the spectral efficiency of up to 7.5 bits per hertz per layer. MU-MIMO layers could now support up to 16 layers in DL and 8 layers in UL. SU-MIMO layers up to 8 in DL and 4 in UL. And there are about 50 slot format configurations, and which could cater to various latency requirements from the applications. Right now we have support of up to 16 carrier components and 16 HAR processes per carrier component, and the deployment wise, there is a flexible RAN architecture. The 5G supports the flexible RAN architecture. So some of the key design aspects, I'm not sure whether you are able to see the screen. Can you zoom?
Yeah. Which part?
Yeah, on the left.
Yeah. Good. This is the zone. I'm highlighting that area.
Okay. So the area that is highlighted, it's on the left side. You can see all the various layers in the combined DU, RU, and CU processing. So right now the highlight is on the DU and the RU, where the Hi-Fi. The physical layer actually is broken into two, the Hi-Fi and the Low-Fi. So this is broken in such a way that the front hole should have the minimum the bandwidth and latency actually. So so basically the essentially what it means is actually for any higher layer higher bandwidth transmissions, right? So like for example, when you want to have a beam forming and all, right, so you are going from port to beams. So when you are going to higher number of antennas, right, so if this split is not maintained, right, so what would essentially happen is you will end up having huge bandwidth at the front hole. So that's the reason the beam forming where actually you are increasing your layers or ports to the antennas, right? So that part actually became part of RU, so that the front hole bandwidth that is a connectivity between DU and RU, right? So it is actually optimized. So this optimized split was defined as part of ORAN. So as part of my team, actually, so we are, if you look at it actually on the DU side, right? So we have multiple various physical, channels like PDCCH, PDSCH, PUSCH. So we actually look at the implementation of all these, all these physical channels in MATLAB, and that essentially will be provided to the software implementation. And also as part of the RU, right? So we look at all the signal processing modules which are part of the RU. So which would include your DDC, DUC, the beamforming, and antenna resource mapping and demapping, right? So the physical channels are modeled and implemented according to the 3GPP requirements defined as part of 38.211 and 38.212. So we implement a lot of proprietary algorithms and proprietary receiver architectures actually. So for the implementations of these channels, and they are actually designed to exceed the performance requirements defined as part of 38.141, 104, and 101. So there are the research contributions and proposals to the 3GPP through technical reports and reports is also handled as part of a team. The physical layer procedure specifications as implemented are implemented according to 38.213 and 38.214. The measurements as part of 38.215 with additional algorithms for scheduling UEs, including pairing of MU-MIMO. And the measurements of 38.215 also required for UV positioning. Between at the interface, right? So we have ECPRI interface specification that is provided by the ORAN groups, and we try to implement these. We have this. In the front hall, right? So we have a control, user, and synchronization plane definitions, and that definitions are covered as part of the WG4 documents of ORAN. And on the RU side, the channel path loss and antenna model specifications are derived from 38.901. So we handle the DDC, DUC design, the up converter, down converter designs, and the FFT transceiver configurations and RF front-end designs are customized as part of the required band and bandwidth combinations for the 5G. And there is, the RU also has to support all the numerologies and subcarrier spacing defined by the 3GPP. And radio conformance requirements should be met as part of 38.141. So, can we go to the next slide? I think, can you zoom on the left? So in this slide, we can see, in the first slide we covered the disaggregation of RU into DU, right? RU, DU, and CU, right? So you can see that it is not limited to one kind of an architecture. So there are multiple possibilities of deployments of when you partition them into RU, DU, and CU. So this slide actually tries to cover where like we have a centralized RAN where DU and CU are part of one entity and called edge site, and RUs multiple and they connect to multiple RUs which are at a single site or on multiple sites. Now another place where actually DU and RU are part of a cell site, and the CU is at the edge actually. So that is called split RAN architecture. So you also have a dual split RAN where we break it up at a higher layer and also at a lower layer. So it's called HLS and LLS, where it's a higher layer split and lower layer split. So the lower layer split is actually you are splitting up the physical layer into RU and DU. and the higher layer split is actually you are splitting up the CU into user plane and control plane. So yeah, I think there are multiple kind of deployments that are possible, and you can see that some more possibilities where actually you can focus on putting the user plane of CU at DU or control plane of CU at DU. So all those possibility permutations and combinations are there. So this is where actually, yeah, I think these slides are all the permutations and combinations of all the, yeah, splits. Yeah, I think from here I will further direct Sudarshan to take over.
Yeah, thanks, Shrini. Although our technology development started a few years back, we started our radio unit related development in kind of end of 2020. Right now, Saankhya Lab is focusing on 3 types of radio units. So one is multi-band, then single band, and massive MIMO type. And these are ORAN and 3GPP compliant. So typically we have kept our architecture as standard. So it consists, any RU from Saankhya Lab consists of 3 major segments. One is TBS or transport baseband subsystem. Second is radio front-end subsystem and power supply subsystem. So we try to keep this modular so that we can scale up and scale down on different types of different bands of RU and different types of RUs which are there. Next slide. So our generation 1 radio as part of customer requirement, we did 2 types of radios, one tri-band and dual band. Each of this is a 44R and FDD system, and we could come up with this solution with various feature sets. In one of the case, we were able to develop and come up with 5cc 5GNR components working over all the 3 different frequency bands, and also support NB-IoT net. And the second type of radio where we have a higher power, working on 4cc spread over these 2 bands. Both of these radios in generation 1 were designed to meet FCC. Today we have this integrated with DU as physical layer, which we have developed in-house. And we have done a lot of conformance test and performance test on these radios. Yes. So traveling from the generation 1 radios, we came to the generation 2 radios, where we are now able to bring, in addition to 5G, 4G related solution. So this we have 3 of this in development process. The first one is the B1N1, where we support 4G LTE, also 5G on the same radio along with NB-IoT solution. And then the 2 of the TDD type of radios, which is 88R kind of size and working on 400 megahertz IPW and 200 megahertz OBW, kind of a large bandwidth radios are in development now, and also massive MIMO. There's a lot of work in terms of feature sets that are possible in both of this TDD solution, because it does support beamforming in various configurations, and then all this generation 1 and generation 2 radios are today it is going for an operator network. These are not a typical what you call prototype products. So these have been developed and productized towards mass deployments. Today we are in a stage of integrating this with actual operator deployed CUs, DUs, and various other subcomponents that are required for complete end-to-end operation. So next, I would hand over to Sunil. He is going to take you through DU related.
Hi everyone, I'm Sunil here. I actually take care of the DU activities at Saankhya. So I'll just briefly tell you what exactly the essential activities that we are doing on the DU side. So, like I think my friend already told about the typical ORAN split, which is currently the split option that ORAN support kind of publishes is actually a 7-2 split, what we call, where actually the RU consists of certain elements of the phi, as well as the DU consists of certain elements of phi, divided as low phi and the high phi. And also there are typical elements of the DU, which are essentially protocol, what we call as an L2 part, which is actually as part of the DU. And then you have the CU split. So essentially, if you see, there is a layer 1, layer 2, and layer 3 functionalities, each differing in terms of the processing that they do. Right? So you have the layer 1 functions, which are signal processing heavy, requiring multi-processor, multi-core architectures. Essentially, you're doing a lot of complex arithmetic there, requiring SMD and VLSI processing elements. And essentially, these require very deterministic processing. So the kind of processors that you need to do a layer 1 functionality versus a layer 2 functionality and a layer 3 considerably differ. Where layer 2 and layer 3 are more protocol heavy, IO rich set of IO functions are required. In layer 2, it's a combination of deterministic and latency tolerant modules that you have. Whereas in case of layer 3, it's typically a latency tolerant processing, but heavy data movement and things like that they have. So the typical architectures was that actually each of these components was going to be implemented on a different processor architecture. But of late, if you see, there have been several different ways the DUs have been realized. One is the typical Intel way of realization, which is currently quite popular, which is the FlexRAM based module realization, where actually Intel has come up with the next generation processors, the Xeon second and third gen processors, which have AVX 512 kind of an highly accelerated instruction set for doing the phi. And also retaining components which you can actually do a protocol. That means whatever we saw here in terms of actually the hi-fi plus the MAC and RLC functionalities are doable on a multi-core Intel CPU, where some accelerations has been done on the hi-fi. On the same, people have Xilinx have also kind of implemented the hi-fi solution as an FPGA accelerator card that sits that goes into a general purpose COT CPU, where your L2 is run and the hi-fi is kind of accelerated on the FPGA. And there are several custom ASIC solutions also currently being worked on by Saankhya. We are also in the works in terms of later on Susmit will briefly tell about that. And NXP, Marvell, Qualcomm, Nvidia, these are the other guys who have actually come up with custom ASIC kind of solutions for DU realization. And there is another camp which is actually working on the open source CPUs like the RISC-V extensions and things like that for doing the hi-fi processing. So what exactly does it take to actually come up with a product like a DU, RU and all, which essentially is what Saankhya is working all about. Is essentially we are talking about a complete product design in terms of industrial designs, thermal simulations are run in order to ensure that your high power RFs are capable of handling, your design handles these high power RFs, high speed board designs, RF and clock simulations. Similarly, like what Shrinivas said, a lot of work in terms of the algorithm development happens. Basically, we do a lot of MATLAB modeling for the various algorithms that we work on. FPGA IP development happens on the lo-fi side. Virtualization is one of the key aspects of 5G. The advantages of 5G being that you can do a disaggregation. So work on in terms of containers, Kubernetes, OpenShift. So these various kind of virtualization component work actually happens. And on the software, everything from actually a low-level coding of assembly coding up to and full stack development in terms of applications for full stack development is done. We work on device drivers, network management protocols like NetConf, SNMP, embedded system software, which includes Linux and RT Linux patches and things like that. So essentially, what you learn as part of your basic engineering is what exactly we do here. So that's a very good place for people to actually migrate from actually academics to actually get into the actually engineering aspects of it. So that's the 5G part of the things actually. I'll just briefly tell about the SATCOM. I also hit the SATCOM vertical within Saankhya. I'll just briefly touch upon what exactly we do at the SATCOM space. So one of the main trend of actually the 5G has been basically the convergence, right? So currently, when we talk about 3GPP, the 3GPP was essentially talking about mostly terrestrial and cellular stuff as we speak. But actually, right now with release 17, there is actually been work that is going on trying to bring in the satellite as well as the terrestrial frameworks into the 3GPP segment. And that is one of the key areas where actually we do work on as part of Saankhya. So just to give you an idea of what exactly a satellite system categorized as, actually you have satellites which gets launched in the geospaces, the neospace and the LEO, which is nothing but the geosynchronous orbits, the medium Earth orbits and the low Earth orbits. These are called, the nomenclature essentially signify at what level, at what higher altitude level each of these satellites are launched. And each of these satellites that are launched have ground terminals which are going to have some unique characteristics, right? So the challenge actually varies when you are talking about designing systems for LEOs, MEOs and GEOs. So we at Saankhya focused a lot on the terminals, and we also deliver we have already delivered a lot of things as far as the geosynchronous orbit is concerned for Earth station equipments as well. So these are some of the, like, going by the SATCOM heritage, that whatever we do have, basically most or all of our designs have been based on our own SDR architecture chipset that we have conceived and architected. Currently, we have more than 2,600 locomotives which have been enabled with Saankhya Labs supplied satellite modems, which are involved in real-time tracking of the locomotives. Currently, we are in the works of actually doing a complete end-to-end system for a vessel tracking for coastal security, which involves supplying the terminals and also giving a NMS application for actually tracking each of these vessels which are there in the sea. We have developed the industry's first S-band sat phone, a complete sat phone, which is actually a companion device for an existing COTS phone, through which you can actually use satellite as a medium for even voice communication. So we are one of the trusted technology partners of ISRO, having expertise in an end-to-end satellite IoT network. And we bring in a unique chipset to system expertise, chipset to platform to system, I would say. And with the unique award-winning chipset that we have had, we have been able to implement a lot of standard and custom waveform developments also on the same chipset actually. So it's this is an overview of the various products that we have currently at Saankhya as part of the SATCOM. It includes the sat phone, what you see here. This is the vessel tracking system which is currently being deployed on for the coastal security. This is the fleet and the vehicle tracker, all these three are with integrated batteries. This is the hub side of equipment, which is actually a multi-channel burst demodulator which we supplied for the Indian Railways project. And we have the locomotive tracker. This is the one that went on top of the Indian Railways for the real-time information systems for tracking the locomotives. And then we have a very, very compact, low-power broadcast receiver, which can receive signals of the satellite. And it's the size of which fits into your pocket actually. So a very compact receiver powered via the USB integrated antenna and all. So this is just to give you an overview of the entire satellite network per se, right? You basically have terminals out there on the field which communicate via either the satellite or the telecom network in terms of if you have a terrestrial connectivity also along with this, and they relay all this information. If the satellite is what is concerned, we have an Earth station which receives the signals, and we have modulators and baseband modulators and demodulators sitting at the hub site, and then tunneling the data onto an NMS, which is there. So as part of the vessel tracking project, in fact, we are delivering the complete web application, the modulators, demodulators, as well as the terminals. So a complete end-to-end system is what we are kind of working on with reference to the satellite space. So yeah, some of the satellite technologies that we are working at Saankhya, it includes low power, low form factor modem designs. So we basically involves a lot of RF design, baseband, and application subsystems. The next generation of SATCOM solutions includes designing things with reference to MFTDMA, NB-IoT, modem solutions. Once again, here also we work a lot on microcontrollers, embedded systems, Linux, and things like that. And of course, a lot of assembly coding also is something that we actually happen to do for our users. So yeah, these are essentially our SATCOM elements that we do at Saankhya. Yeah, I now hand it to Raghu. You are next. So, Raghu will walk you through our BRH.
Yeah, so
Send it to me.
I am Raghu. I'm handling the broadcast products in Saankhya, which is. I just made it. Just a second, please.
Oh, yeah.
I'm talking out of Sudarshan's laptop, so. So I handle the broadcast products, transmitters, and receivers, and the 5G convergence platform. Next slide. Yeah, the next slide, please. Okay. So, direct to mobile broadcast. Slideshow.
It's in PDF.
Yeah, thank you. So the direct-to-mobile broadcast uses the ATSC3 transmission protocol. It's called the next-gen, and it is OFDM based. The advantage is it uses the IP transport system, so that enables convergence with broadband as well. We use a single frequency network, which allows multiple transmitters to transmit on the same channel and with an additive effect. So for single frequency networks, all transmitters need to be time synchronized using a GPS time sync. The ATSC3 protocol also supports HEVC encoding, which is efficient and allows high resolution with high dynamic range and with high frame rate. Apart from that, the standard has defined support for emergency alerts based on if in case of natural calamities, automatic alerts pop up. All of that is defined in the standard. Beyond that, it supports layer division multiplexing, which essentially reuses the same spectrum for both a core layer and an enhanced layer. This allows fixed reception with larger antennas at a higher resolution, with the same thing at a lower resolution, and a lesser mod code is transmitted for mobile reception. So this is some data about why convergence would be useful, especially in the Indian context. So and this data is about the Indian market. So 80% of internet users are accessing the internet on their mobiles. And out of this, 82% is video traffic. And this is growing quite exponentially. And this challenges the wireless infrastructure, right? We have a lot of dropped calls, we have a lot of buffering happening. So if we were able to shift some of this traffic onto broadcast, that'd be a huge saving in terms of cost as well as the speeds available for broadband. And this is what we are developing here at Saankhya. And there is a potential for us and India to become a leader in this convergence technologies. So the convergence is achieved through our Yoga broadcast offload, and it is a software solution that enables OTT operators, say for example, a Hotstar and Disney, to offload heavy viewership content to broadcast. Think of IPL. Think of an IPL match where there are multiple viewers, and if you could only move that entire, the content onto broadcast, you'd save a lot of bandwidth on the broadband side. So this requires a DTV-enabled device, which we have manufactured a phone, as well as we have receiver dongles which attach to our Android phone, right? And we have an OTT app which can automatically switch between content, which is the same content between broadband and broadcast. And the shift between broadband and broadcast is enabled by analytic engines which monitor the users using a particular broadband content. And when that reaches a threshold, the platform initiates DTV transmission of popular content. So the simultaneous transmission in both broadband and broadcast happens, and that allows the users with this DTV receivers on their phones to get out of the broadband system and get onto the broadcast system. So that's pretty high quality content as well. To test out all this, we had a field trial, and this was along with IIT Kanpur and Prasar Bharati. And this field trial happened in Bangalore, and it involved Saankhya design components. One was the broadcast radio head, which is a 40-watt low-power transmitter unit. So this resides on the cell phone towers. We have DTV receivers, a phone, an Android phone, with the inbuilt DMOD, the SL4000 Saankhya chipset, DMOD chipset, as well as a dongle with the SL3000 Saankhya chip for existing Android phones, which attach through a USB to the existing Android phones. The app associated required for DTV reception is inbuilt in these. And the third is the Yoga broadcast offload system, which allows the content to be offloaded from broadband to broadcast. Some general information about the field trial. We had 3 units transmitting. We've been transmitting for almost a year now in Bangalore at 590 megahertz. And all the components, the receiver, the transmitter, and the offload have been tested. The single frequency network functionality works as expected. We get additional SNR as compared to a single transmitter reception. moving vehicle tests, one of the primary reasons for D2M are, people are mobile. So apart from low speed mobility like walking, high speed mobility through vehicles was also tested. So that works as expected. The next plan is to expand to a larger field trial and try. We plan to use existing high power, high tower transmitter. One of Prasar Bharati's existing transmitters converted to this next gen transmission. Along with that, Saankhya Labs low power transmitters would be the gap fillers, where there are gaps within the coverage platform. So with that, internal very good interior coverage as well as mobile transmission is expected. Thank you.
Hello, can you hear me? Hi, I'm Susmit Datta. So I lead the IC activities at Saankhya Labs. I've been in the industry for several decades and in Saankhya Labs for more than 10 years now. So let me share my screen. Can you see my screen?
Yes.
Okay. Okay, thank you. So I guess you have heard about us from all the speakers before me. So I'll try to add on to that. So as you would have realized, we are quite. I hope you feel that we are justifiably proud of what we have done here in terms of the IC work. So we are the first Indian fabless wireless semiconductor team. As Anindya mentioned right at the beginning, we have realized a wireless platform based on software-defined radio principles completely from scratch. And that's no mean achievement. I mean, the founding team, of which many of whom are here in this presentation, they did that, at the starting days of the company. So basically, in terms of strengths, we are backed by strong wireless and DSP domain knowledge, and we pride ourselves in our ability to translate application knowledge into solutions. So basically, the thing is, there are maybe a lot of engineers and also teams in India today who can write RTL, who can do verification, who can do synthesis, and who can do tape outs. But the thing is, there are not that many who can deliver the complete solution. Like whatever Raghu was talking about, let's consider our engagement with Sinclair Broadcast Corporation. So they came and told us, look, we need a mobile wireless broadcast receiver. I mean, it was a one-liner wish, right? And we had the ability to take that and take it through the entire life cycle into the finished IC product. So that's beyond just IC design or VLSI design only. And that's the thing that you get if you are a part of Saankhya Labs. So we can do this because we have more than 15 years of wireless experience. And I think, again, somebody mentioned it already, that we do everything from antenna to bits. So every aspect of wireless, which means, more than wireless, because suppose, for example, there's a PCI Express interface in some chip, it means that, yes, you need some good working knowledge about those interfaces. You need good working knowledge of board design practices, high-speed design, and so many other things, right? So it's the complete package that we offer. So when we do IC design, we design something that fits into the overall picture. And I mean, we don't just write RTL or, do the other smaller steps. So basically, I guess that makes it obvious that our skills, when it comes to our skills, we are good at definition and architecture. and we believe we are creative in balancing programmability, area, and power. So we believe in this software-defined radio approach, where we have a good amount of programmability in our designs. So, I mean, our chips have gone beyond the applications they have been originally designed for, and all this has been achieved with very small, with very limited area and power. So that's quite a good, that's a feather in the cap. So there's an important project management aspect, because one thing I would like to say here is that we have been around for some time now, and we have relationships with a very large number of people in the ecosystem here. And we work with many other companies, and we have the ability to pull together people of diverse skills and profiles. And what happens is, say, if I talk about an IC project, so the internal team plays a key anchor role. Like when we were doing the previous tape out, like the internal team was smaller, but at the peak, the overall team was more than 50. And many of them were, external consultants and all that. But the internal team was what was holding the whole thing together. The key knowledge resided with them. So that's again another aspect that we can manage the whole thing. That's important. So the cross functional skills, we believe that they are needed, so only IC and VLSI skills aren't enough. So now that I have talked about the overall things, let me cover this sidebar where I have tried to cover in short the different phases that we go through when we are doing an IC delivery. We of course starts from requirements, and typically they are one-liners, the kind that we talked about, like what was given to us by Sinclair Broadcast, or what we are doing with Himalaya now. Like in Himalaya, the statement is that, okay, go and design a open run solution. And that's very amorphous, but we have come a long way from that already. So in the definition and architecture phase, we work closely with the software systems and algorithm teams who are all represented here. You'd have seen Sunil and Sudarshan and a lot of other people, Shrinivas. So all of their inputs go into the definition, because otherwise the product will not come out right. And it's a joint effort that results in effectively deciding what is to be implemented. So once the architecture is arrived at, then we go to an RTL coding phase where we actually implement the design. So far we have used Verilog, system Verilog, but we are increasingly moving to more and more sophisticated flows when it comes to design implementations. So once the design is implemented, we verify it, of course, and we have used system Verilog and UVM methodologies. Again, when I talk about RTL coding verification, there are two levels we can think of. One is the IPs, the individual IP modules, the functional modules that need to be designed and verified. And then they are stitched together at the top level of the SOC, and the whole thing needs to be verified again, right? So, I mean, there's a IP level and an SOC level verification, which is not really represented here. I had limited number of slides, so I could not do that. So once that's done, then we synthesize it. It turns into, gates, timing constraints and all that. Then it goes into physical design. So physical design is something that we don't do internally at Saankhya Labs. So we rely on an external partner. So the external partner takes care of this part of the design cycle. And we are closely working with that external partner all the time, because eventually we are responsible for the outcome. So after the physical design is complete, then there's the static timing analysis. And the physical design, static timing analysis, synthesis, this part is actually iterative. We go through several iterations until we achieve the required frequency, area, power, and all those parameters, right? Here I have used some color coding. The green color represents the work done by the external partner. And the physical design, as I told, like it's completely under ownership of that other company, whoever they are. And the timing analysis is a shared responsibility. That's what I've tried to show here. And once we have gone through all this, then the final tape out happens, right? So then, of course, after the tape out also, once the silicon comes back, then you have to validate it. You have to take it through all the testing and all that. And you have to do many, many things until it is fully qualified for production. But that's again a fairly long cycle. I mean, it's takes several months, which is not shown here, and that involves several partners. But this bar which you see, these steps are the main things that are done by the Saankhya Labs internal team. Okay, so I'll move on to the next slide. So I know I'm the last guy, so please prompt me if I'm consuming too much time. So what's the work that we do at Saankhya Labs? So what we have done in the past is that we have started with software program, digital TV modulators and demodulators. But as I told, they have gone beyond what they were intended to do originally. Like if you have heard Sunil, we have Sunil, Raghu, we have gone into satellite, we have gone into broadcast, and we have gone into rural broadband, many things. So that is enabled the program by the programmability. What we are doing now is we are currently working on IC as well as FPGA solutions in the 5G network infrastructure, right? That also you have heard. So basically, I mean, many people in our team, they move back and forth between IC and FPGA. So the basic skills needed are the same, but of course there are certain, specialized, aspects that are involved in each of these areas. But we are developing expertise in all of these. So what are the things that we work on? One is specialized CPUs. I think Anindya briefly mentioned it. We have our own instruction set architectures. We implement signal processing functions like FFT, complex arithmetic, and all that. So we have VLSI implementations, right? So we are good at implementing very specially designed CPUs that optimize power and area. But I mean, they are very, very good for wireless specific and domain specific applications. They are much more efficient than other off-the-shelf processors. In addition to CPUs, there are also domain specific accelerators, like which are custom built for specific purposes. I have listed a few here. For example, we have an adaptive filter. We have several flavors of forward error correction. We have programmable we have programmable FIR filter chains, and many things like that. Also, for the SoC integration, we use various DMAs, interface logic, debug logic, different SoC level glue logic, testability support logic, and so on, right? So, I mean, in putting the entire SoC together, you need, many, many things to realize the whole solution. Okay. So this is a slide that, I put it together to capture the different kinds of products that we have done. The first generation products were programmable multi-standard wireless solutions. So they involved heterogeneous VLSI CPUs, adaptive filter accelerator, FEC accelerator, and various interfaces. So the second generation, what we did is we brought in the mobile aspect, right? When it comes to IC design, that meant being even more stingy than usual about the power, right? We developed the expertise to do power islands and all that. And if you have heard from Raghu, like the ATSC 3 standard, it included newer features like LDM, layer division multiplexing, and all that, which needed certain architectural enhancements, right? So we did all that, all at uh, area and power that was suitable for mobile applications. But at the same time, we did not erode the support for earlier Gen 1 standards. It still remained a multi-standard implementation. I also want to mention that in collaboration with the external partner, we have done a specialized MCM meant for cell phones. That's the SL4000 product. So that actually packages our IC and some other components into a single tiny chip, which goes into mobile devices. So that's in use now. So for the third generation products, we have gone on to something completely different now. We are working on the Open RAN applications. It's a, big leap of faith for us, which we are enjoying. We are going through the virtualization cloudification world, high throughput processing, and this is under development. And I also wanted to mention that we have done a lot of FPGA implementations, and we are doing that. So there are a lot of high complexity FPGA implementations currently being tested in the lab for the ORAN radio units. We have also done many other FPGA implementations in the past, whether it's satellite, defense, broadcast, rural broadband, and all that. So as a result, we have developed plenty of lab and debug experience. So overall, we have a rich set of experience and capability within the IC team, and we hope that we'll continue to enhance that in the future, and we will continue to explore newer and new areas as time goes along. So yes, I think that's all I had to say. Thanks for the opportunity. So I'll end my presentation here. Thank you very much.
Hi everyone, good afternoon. This is Soumya. I take care of the HR function here. I hope I'm audible and my screen is visible.
Yes.
Yeah, thanks. Considering the time, I would like to, just brief on the current management structure and the opportunities that we have here at Saankhya. We've seen all these, taken through by our core team who are here in the panel. We've been, we were incorporated in the year 2007, like 15 years into the industry experience. And on a timeline based, we see, where we started as a semiconductor company, and then, that's where we are here right now. And that's on the timeline base where we plan to go. So this is where I wanted to throw some light on the management or the founding team. Mr. Parag Naik, who's our founder and CEO, our CEO Vishwakumar Kairgade, and Hemant Marlapur, also one of our founder, who's EVP of engineering here. Then there's Anindya Saha, who's also present in the panel today, our chief technical officer. Preeta Mutaya, who takes care of the marketing strategy portion, and Vivek, who is part of sales and business development. They all accommodate into the core team or the management team, if I have to be more specific. So in board of directors, we have Mark Etikin, who's SVP in Sinclair Broadcast Group. From board of advisors, we have Kiran Deshpande, Abhay Karandikar from IIT Kanpur, and Mr. Amar from Executive Vice President and CFO of Rackspace. So moving ahead, I think these are the product and solutions. It's been covered by our panel members here. Just want to throw some light on what exactly are we looking forward in terms of hiring talent. So since we have a wide range or a huge spectrum of team or should I say departments here, starting from algorithms to RF to chip design, right? Then hardware engineer, that's what we call a system engineering internally. And then, of course, we have something in the mechanical design engineers also for the designing the electronic products. So people can drop in their resume at team.hr@Saankhya Labs. They could directly connect to us or log into our website and explore the career opportunities that are there. We look forward to hire people from IT Mandi. I think being mindful of the time, I would like to end the presentation here, and we are open for questions.
Thanks, Soumya. If any of you have any questions, you may use the Q&A tab or the chat or raise your hand and we'll let you on the stage. It doesn't look like there are any questions. Satyajit, is it okay to wrap the session?
Yeah, I guess because it's 12:30 to 1:30 is a lunchtime, and then we have other talks lined up. So I think
Right.
many people have headed towards their lunch. Yeah, but
Okay.
I must say it's very interesting and a very detailed presentation. And I thank Saankhya Labs team for putting this together. And I'm sure this is going to be very useful to all students as well as those who are considering R&D in industries. And these sessions will be available as well later on. So yeah, we'll make sure that it reaches to the right audience later as well. Thank
Satyajit,
you.
there's one question in the Q&A tab. Maybe we can take it
Yes,
quickly.
yes, sure.
The question is, what is the process for hiring engineers at Saankhya Lab?
I would like to take that question, Sharayu.
Sure.
Yeah. So the process for hiring fresh engineers is, once they send in their application to the website or the email ID that I mentioned, there will be a written test based on the interest they have shown, be it software or algorithms or VLSI. There will be an aptitude and a technical, online test. Based on the test scores, we will have an interview panel who will talk to them and then finalize on the process. So we usually tend to, we emphasize on internship plus full-time opportunity so that the student gets a lot more view into the company when they come and do the internship before they get into the full-time employment. I'm dropping the email ID here as well so that, they can send in their resumes or their application here.
Thanks. I don't see any other questions, so maybe we can wrap up the session. I would like to thank all the panelists for their time to address all the students, and I hope it'll be a mutually beneficial association for Saankhya Labs as well as the students who attended this session. Thank you.
Thank you, Dr. Sharayu. Thank you, Dr. Satyajit, for the opportunity.
Thank you.
Thank you. Thank you all.
And thank you all my team for being around. Thank you.